Hi, my name is Ed Goad, and I'm an instructor at Green River College. In this video, we're going to talk about an introduction to access control lists, what they are, what they do, how they work, and why we would use them in our environments. In general, access control lists help us identify, quote, interesting traffic. Now, interesting traffic could be based on applications. For instance, various applications I might have in my environment might be a web browser. Maybe I want to allow HTTP or HTTPS in my environment. Possibly email. Maybe I want to allow or not allow email in my environment. Maybe various social media, games, video streaming, or other types of applications in my environment. Along with applications, we can also manage different types of protocols. For instance, perhaps I need to manage all of the TCP traffic in my environment, or all the UDP traffic in my environment, or the routing protocols such as BGP or OSPF or other routing protocols in my environment. Access control lists help me identify that traffic that I can then manage further on. I can also look for individual hosts or ranges of hosts. And using those hosts or ranges of hosts, I can allow, deny, change the traffic, and so on. For instance, perhaps host A cannot talk to host B. I don't want host A to talk to host B, so I need to block it. Perhaps I don't want people from outside of my country accessing my website, so then I can use an access control list to block entire ranges of traffic from my website. I can also even identify, say, established connections. All of this up here, maybe that takes a little bit of processing power, a little bit of time for all the traffic to go through my firewall or my router or wherever my access control lists are hosted. And therefore, I then want to help identify if traffic is already established, then ignore all of those up above and just go ahead and follow through with the traffic because we've already established that that was good at that point. All of that would be considered our interesting traffic. Once we've identified the interesting traffic, then we could start shaping it. The most common method of shaping of our traffic is going to be allowing or blocking, sometimes permitting or denying our traffic. This host is allowed to talk to that host. However, it is blocked from talking to this other host. However, we can also use access control lists to prioritize our traffic. For instance, do I want to allow video gaming on my network? Maybe, but it should be a lower priority than other traffic on my network. Therefore, I will prioritize it as a low quality of service over the email and web browsing that's going on in my environment. I can use my access control list to encrypt traffic over VPN. Perhaps specific traffic needs to go out across the VPN to a remote location. The access control list will identify that traffic and then initiate the VPN connection and encrypt it across the internet. Establishing connections. I can use an access control list to help establish a redundant connection or a backup connection. Perhaps my WAN connection or my internet connection is getting overwhelmed. Therefore, I can establish a redundant connection that will increase my bandwidth and allow the traffic to go through better. Even translating the traffic, such as using NAT and many, many more. In this video, we're going to be talking about this basic network right here. There are 3 different networks. There's an accounting network, a marketing network, and a server network, and a router in between, which is where I can host my access control lists or ACLs. Each of those networks has a couple of different hosts, A and B in accounting, G and H in marketing, and then servers Y and Z in the server network. We'll be coming back to this network in a moment. When talking about access control lists, in general, we have two different types. We have a standard versus an extended access list. Standard access lists are extremely lightweight. They don't take a lot of processing power and oftentimes are faster than extended. So if speed and performance is of a concern, that might be where we want to look. However, they're not as flexible. As we can see, a standard access list looks only at the source IP. For example, let's say that my security department comes along and they say, hey, the accounting department should not be accessing the server network. They should not be able to get through there. Since the accounting department in this scenario is all on one network, I can easily look at the source IP and block that source IP from accessing the server environment. The marketing department then, since they're coming from a different network, would then have access to the server environment. Fairly easy. However, if we start getting into any more of a complex environment or complex connection, such as in accounting, machine A can talk to server Z. However, machine A should not be able to talk to server Y. Then we start getting more complex configurations because the source IP in this case is the same. It's still machine A. However, the destinations are different, and therefore a standard access list will not work. Because of this, we then also have extended access lists. Extended access lists utilize not just the source IP, but the source port, destination IP, destination port, and protocol. These are sometimes referred to as the 5 tuples. There are 5 of them, and therefore it's the 5 tuples. With the scenario we had just talked about, to where server A should not be able to talk to Y, I think that's how I said it. However, accounting A should be able to talk to Y, but not to Z. Maybe if I said that correctly. Based off of both the source IP and the destination IP, the source IP in this case is the same. It's still machine A. However, the destination IPs, Y and Z, are different, and therefore I can start using my extended access lists to include that. As I look at the other options, for instance, I can look at source and destination ports. So I can start defining which applications, such as HTTP versus HTTPS, FTP, SSH, SSL, Telnet, email. I can start identifying applications that I want to permit or deny throughout my environment. And then even protocol, while for the most part, when talking about access control lists, we're going to be talking about TCP or UDP. The protocols also come in to where we can start talking about ICMP, OSPF, RIP, and many, many more. So it's much more capable than what I have identified, but this is just an introduction. As far as applying those access control lists, there are a couple of different places we can apply them. However, in general, we can have only one access control list or one ACL per interface and per direction. For instance, going back to that sample that I gave to where the accounting should not be able to access servers. In this case, I can see I'm going through 2 interfaces. I'm going there and there. As the traffic goes that direction on this interface, on the accounting interface, the traffic then is considered to be inbound, according to the router. As I hit the second interface, or the server interface, it is then considered to be outbound. So I could put an access control list on either the inbound accounting side or the outbound server side. I do have to be a little bit careful because I can only have one, in general, only one access control list on either of those interfaces and direction. So therefore, I have to make sure that all of the traffic I want to manage is included in that one set of access control lists. General rule of thumb, as we're talking about standard about access control lists, a standard access control list should be as close to the destination as possible. So in the scenario of the accounting department not being allowed to the server department or to the servers, I would probably want to put it on the server side interface in order to keep the ACL as close to the destination as possible. However, when we're talking about extended access lists, it should be as close to the source as possible, which means I would want to keep that as close to the accounting side as possible. As a general rule of thumb, this is not always the truth. However, it is a general introductory suggestion.